define a statistic U, then which of the following statements is are correct? So we need to check whether U is an unbiased estimator of P into 1 minus P over N, and whether U is UMVUE, and whether summation of Xi is complete sufficient statistic for P or not. So first of all, like if we consider this distribution, like we are having x1, x2 and so on xn, this follows binomial n comma p. So U is nothing but 2 by n if x1 plus x2 is equals to 1 and 0 otherwise. So expectation of U is nothing but 2 by n into probability of x1 plus x2 is equals to 1. Now probability of x1 plus x2 is equals to 1 we can find, because like we were given x1 comma x2 follows binomial n comma p and they are independent. So therefore the probability of x1 plus x2 is equals to 1 is nothing but probability of x1 is equals to 0 comma x2 is equals to 1 plus probability of x1 is equals to 1 and x2 is equals to 0. That means this is nothing but 2 times of probability of x1 is equals to 1 into probability of x1 is equals to 0, because x1 and x2 are IID. So probability of x1 is equals to 1 is nothing but n choose 1 into, so this is nothing but 2 times of n choose 1 into p into 1 minus p whole to the power n minus 1, and probability of x1 is equals to 0 is nothing but 1 minus p whole to the power of n. So probability of x1 plus x2 is equals to 1 is nothing but 2 times np into 1 minus p whole to the power n minus 1 into 1 minus p whole to the power of n, which is nothing but 2np into 1 minus p whole to the power 2n minus 1. So that means we can clearly see expectation of U is nothing but 2 by n into 2np into 1 minus p whole to the power 2n minus 1, which is 4p into 1 minus p whole to the power 2n minus 1. And we can clearly see it is not equals to 1 minus p by n. So therefore statement 1 is false, that U is an unbiased estimator of p into 1 minus p by n. Now if we consider the second statement, they are saying like U is uniformly minimum variance unbiased estimator of p. Now we can clearly see U is not even unbiased for p or any linear function of p. So we can clearly say that this is not even true, because it's not even unbiased. Now third statement says summation xi is complete sufficient statistic for p. Now we know that this xi follows binomial n comma p and they are independent, and summation t is equals to summation xi, this follows binomial m into n comma p, and we know that this binomial is a part of, binomial family is a part of exponential family, so therefore the sum is a complete and sufficient statistic. So that means the statement 3 is correct. So statement 1 is wrong, statement 2 is wrong, so statement 3 is correct, so option B is correct.